We're beginning with semester review question 39. We've got to practice making trig wave graphs. So a quick review here. Remember that this plus 1 could just as easily be plus 1 behind this value. So what do we know here? This is going to be a shift up 1 unit. It has a negative multiplier, so it's going to have a vertical flip. We know that the amplitude value A here is going to be 1/2, and we know this value in front of the x is coefficient B. So amplitude is the absolute value of A. In this case, that becomes 1/2, make it positive. Our period width is normally 2 pi, but we have to divide if there's a coefficient of B. So in this case, 2 pi divided by B has a value of 2. So our period width is pi. There is no phase shift. A phase shift is if it had x plus or minus. So if there were a horizontal transformation. And here there isn't. So we start at 0 and we travel for 1 period width. That would end at pi. So we do have to shift everything up 1 unit though. So if I choose a height here, let's make this our new axis. Everything is going to shift up 1 unit. And then if that's a height of 1, then I want to mark our amplitudes. This would be at 3/2 and this would be at 1/2. And then our period width goes from 0 over to pi. So if this is a value of 1, remember we want to make it look reasonable. So let's go about 3 times that distance. And then let's always remember to divide that period width up into 4 equal quadrants. So this would be pi over 2 in the middle. So this is pi over 4. And this is 3/4 pi. And this is 0. So always have 5 marks on your horizontal axis and at least 3 on your vertical axis. All right, now we got to remember this vertical flip, this negative sign. So think what cosine normally does. Cosine normally starts up at its amplitude and goes down. So if we flip this upside down, we better start at our minimal value. We better start at our minimal amplitude, and then we'll go up. And then we'll go to our maximum, back to our axis, and then down to our minimum. And then remember always to make these curves, not V shapes. And we've already got the graph labeled, so that's all there is to it. Let's try another one. And what do we have here? We have a phase shift this time. So this is this horizontal slide. So what do we want to do here? First, we want to rewrite this. This is a 1/2 times x. So remember what we want to do with that b value is bring it out of the parentheses. So we want to factor 1/2 out of each of these. Factoring 1/2 is dividing by 1/2. So to divide by 1/2, we multiply by 2. And if you doubt your arithmetic, distribute to see that you get back where you came from. So this value right here tells us about our phase shift. So remember that horizontal transformations go in the opposite direction. So our phase start here we can see is going to be at -2 pi. So don't make those more difficult than they have to be. Okay, what's our amplitude? Here's our value of A. So our amplitude is 2. Our period, we better take 2 pi and divide it by B. 2 pi divided by 1/2. To divide by 1/2, we multiply by 2. So our period is 4 pi. If we start at -2 pi and we travel 4 pi units, aren't we going to finish at +2 pi? So let's get our graph labeled. Let's use all the space we've got here. So I'm going to pick -2 pi here. That puts +2 pi here. And that's pretty easy to divide. Since that's a width of 4 pi, we can count by pi's. And if that's our width of pi, remember that distance is about 3. So 2 would have to be smaller than that. So our amplitude up at 2 and down to -2 And let's remember that we're graphing a sine wave here, so let's think about our normal sine function. Starts at 0 and goes up. Did I draw that? Let me erase and draw that one more time so it's very clear. Start at 0 and go up for sine. So our starting position here is at negative 2 pi. There's no vertical transformation here, and there's no vertical flip. So I simply start at our axis value, and then I go up to our maximum, back to the axis, down to the minimum, and back to the axis. So our sine wave here, again, make sure you make it look curved, and make sure you don't miss your points like I was just going to do there. Make sure you hit each of your quadrants. And you can graph more than one cycle, but as long as you label one cycle, that's good enough for me. All right, let's try one more, and it looks like I covered up my problem. Let me pause a second and check out the problem. Okay, now we can see what the problem is. We've got to graph a cosecant function, and what I would suggest doing first is do the sine wave that looks the same, and then flip over your curve. So again, we've got a b value here of 1/2, so I'm going to factor that out of both of these terms. So when I factor 1/2, I have pi over 2 left here. Make sure if you distribute that you get back where you came from, so you know you did that correctly. So here we know we've got a phase shift. We go in the opposite direction horizontally. So our phase start is going to be at pi over 2. And our period width here, we're going to take 2 pi and divide it by b. And this is just like the one we did a minute ago. We can see our period width is 4 pi. So if we start at pi over 2 and we travel 4 pi, we're going to end up at 4.5 pi. So I'm going to write that as 9/2 pi. So if I pick a value here for pi over 2, and then we just start, let me just mark these off and then we'll count them out. So if every one of these is pi over 2, that's where we're going to start. So here's pi, and there's 2 pi, and 3 pi, and 4 pi. So here we're going to end up at 9/2 pi. So we can label these in the middle. Here's 7/2 pi, here's 5/2 pi. And these might be getting in our way here, 3/2 pi. So which one's divided into 4s? I could get rid of these so you can see that we've got it divided up into 4 equal parts there. So however you want to do that. So we're going to start at pi over 2, go to 9/2 pi. Our amplitude is 1, so look at how shallow our graph is going to be here. If this width is pi over 2, then 1 is even smaller than that. So we'll pick these values for 1. And now I'm doing a sine wave first, and it has an amplitude of 1, and it is not flipped over. So I'm going to start on our axis and rise, and then go down here and then back here. So we've got a very shallow, and I'm doing it dotted because it's not really what we're interested in. The sine wave isn't what we were asked to graph here. Let me move this label if I can. This label was 7/2 pi. Okay, what we were really graphing is cosecant. So now remember that the reciprocal of 0 is undefined. So the cosecant is undefined wherever sine is 0. You already knew that. The reciprocal of 0 is undefined. So if you were asked for equations of these asymptotes, you would say pi over 2, 5/2 pi, and 9/2 pi. And then we would flip over these curves into these U-shapes. And that's our cosecant graph. All right, I think we can continue a bit here. Let's see what else we can get done in this video. Our definitions of trig ratios, we had 2 different sets. In the unit circle, when the hypotenuse is equal to 1, sine is the y coordinate, cosine is the x coordinate, tangent y over x, cotangent, flip it over, x over y. cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. And in SOHCAHTOA, if we had triangles that didn't fit in the unit circle, then we did opposite over hypotenuse, adjacent over hypotenuse, opposite leg over adjacent leg. So reciprocal, adjacent leg over opposite leg. Cosecant again is reciprocal of sine, so it's hypotenuse over opposite. And secant is reciprocal of cosine, so it is hypotenuse over adjacent. Now, whenever we say adjacent now, if we're thinking unit circle, you can think horizontal segment, and vertical is the opposite leg. Okay, some trig identities. 3 Pythagorean identities are basic ones. Sine squared plus cosine squared is equal to 1. So then if we take that and we divide it, let's say, by sine squared divided by sine squared, cosine squared divided by sine squared is cotangent squared, and 1 divided by sine squared is cosecant squared. And let's go back to the original. Let's see what happens if we divide it by cosine squared. So sine squared over cosine squared, tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared. So you should be able to quickly come up with these Pythagorean identities. All right, so let's rearrange them then. What if we tried to get 1 minus sine squared? Well, look at what we're doing here. What if we move this sine squared to the other side? So 1 minus sine squared would leave cosine squared. How about cosecant squared? Well, we've got it right here in front of us. Cosecant squared is 1 plus cotangent squared. And how about tangent squared plus 1? Right there in front of us, that gets replaced with secant squared. So you should be able to recognize when to use those Pythagorean identities. Cofunctions means complementary angles. And remember where this came from. We did this many times where we said if this value is x, this other angle is pi over 2 minus x. And the sine of one angle is the same as the cosine of the other. So the sine of this angle is the same as the cosine of theta. The secant of one of those angles is the cosecant of the other. And the cosecant of an angle is the secant of pi over 2 minus that angle. So I didn't give you any there using tangent, so that was a bit of a trick. All right, so if we are given the value of the sine of 17 is something called a, then what can we conclude using a cofunction identity? We know then that the cosine of its complement, so pi over 2 is in radians, so here we want to switch to degrees. So of course, you don't have to show this. You guys know that the complement of 17 degrees is 63 degrees. So we know that the cosine of 63 degrees would be also equal to a. All right, negative angle identities. Let's see if I can remind you where they came from. If we had this angle x and we did its opposite, we're down below it. So think what happens. How do you compare these 2 points? Do you see that they have the same sine? The same cosine, but the opposite sine. So the sine of a negative angle is the opposite value of the sine of the top angle. The cosine of the negative angle, though, stays exactly the same as the cosine of the original angle. The tangent of the negative angle is the opposite. So sine and tangent work alike. And then we just match these up. Cosecant does the same thing that sine does. Secant does the same thing that cosine does. It does not change signs. And cotangent changes signs just like tangent changed signs. And you have these on your resource page, but I hope you don't need to refer to that.